Hi again, Pre-Calc class. Today we're going to learn about hyperbolas, lesson 10.4. So here's the official definition of a hyperbola. You can notice it's fairly similar to what we saw with the ellipse the other day. Again, set of all points in a plane, but now the distances from the two foci. With the ellipse, you might remember it was the sum of those distances, but notice with a hyperbola it's the difference of those distances. So because of that fact, the hyperbola then, rather than opening inward, the hyperbola opens outward. But we still have those two focal points. Notice where they are. They're in a sense inside that hyperbola, or inside the curvy part. Still have vertices, really just two of them now. And we still have what's called a major axis and minor axis and things like that. But that's the hyperbola definition. Here's the axes that we have, kind of like the major axis, except here we call it the transverse axis. So as you can see with this hyperbola with the horizontal orientation looks like that. Then we also have the conjugate axis, that's kind of like the minor axis. Now the asymptotes, which we'll see, help us in graphing these hyperbolas. They're not really a part of the graph, but like the asymptotes that we've seen before, the horizontal and vertical ones, these are more diagonal ones. They do cross through the center all the time and help us when we do some graphing. Here's our standard form once again for hyperbolas. You'll notice this looks very similar to the ellipse. We still have a couple of fractiony looking things. We like to have it equal to 1. H and K are the center once again. We have our A squareds and B squareds. But notice the key difference between the hyperbola and the ellipse then is our signage. With the hyperbola we have a minus sign in there. Also notice a key difference which we'll see is A squared always comes first. A squared always comes first. That tells you the orientation of this hyperbola. This one will be a horizontal one simply because that term with A squared is x, which would make it a horizontal orientation. This one, A squared comes first, and since it's under the y term, this one will have a vertical orientation. Now, the big difference between ellipses and hyperbolas, other than their shape obviously, is that this A squared always has to be positive. A squared comes first. And listen to this, A squared is not necessarily the biggest value. A squared is not necessarily the biggest value like it was with ellipses. So again, ABC is kind of important. We saw that with ellipses to help us figure out either one or more of those values. Here the relationship is almost Pythagorean-like. C squared equals A squared plus B squared. Again, the significance of C is that it is the distance of that focal point from the center. And of course, A and B have to do with that major and minor axis. But this is a key relationship for you to... All right, let's actually do a little graphing here of this. Let me get my pen thickness and colors going here. So again, as we might expect here, the center for this one would be at 2 and negative 3. So I'll see if I can find that. So over 2 and down 3 looks like it'd be about there. Now the difference with a hyperbola when we graph it is, in a sense, we try to make a little box. So here's how this is going to work. I notice my horizontal axis right here has the 36 underneath it. So that means on the horizontal ways I'm going to count over the square root of that. So I'm going to count over 6. So that's going to take me right about to there. I'm going to count 6 the other way, which will take me to negative 4. Okay. Then on the y side of things, the vertical axis, I have a 4, so that's going to go up 2 and down 2. Now what I'm going to do here is essentially make a little box with those borders as the dimensions. So it's going to look like that. Now again, that's not a part of the graph, but it's going to aid me in graphing it. Now through that box, through the diagonals of that box, I'm going to actually draw some diagonals like this. And it does have to go through the center of that hyperbola. So that gives me some guidelines here in drawing this. Now, because this x value is first, not because that this 36 is bigger than 4, which it is in this case, but simply because x comes first, I know that my hyperbola is going to have a horizontal orientation. So it's going to look similar to this. Again, I just follow the guidelines of those diagonals I drew to draw my hyperbola. So there it is, fairly similar in a lot of ways to how we graphed ellipses, but a couple little different twists. Okay, here's our general form once again. Ax squared plus cy squared looks very similar to what it did with ellipses. However, a little bit of a misnomer here, perhaps. Oftentimes this will be a minus sign right here. Now c can be a negative value, as we say, but the way you'll be able to recognize a hyperbola in this general form is that a and c here will have different signages. Typically this a will be positive, this will be negative. That's how you'll recognize whether you have a hyperbola on your hands. So what I'm trying to say here, hyperbolas in general form will always have a negative sign, is what I think I was trying to say here. We'll always have that negative sign. Alright, here's kind of a tough problem that we're going to see if we can tackle here. I want to try to graph this. Now again, this is in this general form. Looks a little bit nasty. Again, I'm going to try to group all my similar variables together. So I have my 4y squared plus 24y. In this case, I'm going to change colors here and go to my orange. And so then I have my x squared plus 4x, like that. Actually, negative x squared. And then all that, of course, is going to equal negative 28 for now. Again, I'm going to try to do some factoring here like I've been doing before. Noticing with my y values, I can pull out that 4 and get y squared plus 6y. Noticing difference of, completing the square here. Half of 6 is 3. 3 squared is 9, of course, so I'm going to add 9 here. What do I add to that other side? Again, not 9, but 4 times 9, which is 36. Doing the same thing with my x's here. Completing the square here, and I don't have to really do any other factoring, it looks like. I'm going to have x. Let's see, I'm trying to think about what to do with that negative sign. That's always a little bit pesky here. So it's going to be like minus x squared minus 4x, like that. So if I complete the square here, what's actually going to go in there is a plus 4, I think, right? Half of negative 4 is negative 2, and square that, I get plus 4, like that. So it looks like I'm adding 4, but again, because I have the parentheses here and that negative sign there, it looks, in a sense, I'm really subtracting 4. So then I better subtract 4 from this side too. And so I think what I end up with here, out of all this now, when I do it, I'm going to go to a normal color. I'm going to have 4. This is going to be y plus 3 squared minus, this is going to be x minus 2 squared. And then out of all this, I think I'm going to get plain old 4 here. Again, I like to have it equal to 1, so I'm going to divide everything by 4, as I can see there. So it looks like my final answer will be y plus 3 squared minus x minus 2. Notice I do have a 4 in the denominator there, equaling 1. So just to be consistent, I'm going to put a 1 under there like this. So it looks like my center is going to be negative 3, positive 2. Right about there. I'm going to count over simply just 1 on the y side of things, I think, up 1 and down 1. On the x side of things, over 2 and down, or across 2, like that. And I'm going to try to make my little box here. Draw my diagonals through there. It's a little bit tricky here. So now the question on this one is, what kind of orientation does it have? And simply, the main thing to look at, even though this seems kind of strange, the main thing to look at is only what comes first. And so because that y term is first, that's the orientation it has. And so this is a hyperbola that's actually going to open upward and downward like this. So don't be deceived by those values in the denominators, especially when we think in terms of those ellipses, because with hyperbolas, it's what comes first. Just to finish up here then, remember that hyperbolas should not be confused with that English word hyperbole. Here's our familiar phrase, raining cats and dogs, the literal sense of that. This is different than that, as you can see. Also different than my description of how I got to school, of course, when I was your guys' age, going uphill to school, both there and back. That's a diagram of the route that I took. Anyway, thanks for hanging in there. We'll continue to work on this in class tomorrow. See you then.